Open. Hello? Can you hear me?
Yes, I can hear you.
Okay, we will open all sessions. Just give us like 5 minutes when we will open all sessions.
Take your time.
Okay. Can you hear me very well?
Yeah, yeah.
Okay.
السلام عليكم. السلام عليكم. العفو، الأخوة الموجودين ممكن يوضحون نحاول ندخل على روابط الزوم وغير مفتوحة في الغرف الأخرى، فهل ممكن يعني أحد موجود ممكن يساعدنا بهذه النقطة؟ أرجو من الأخوة القائمين على المؤتمر يحاولون أنهم يفتحون باقي السيشنز. حتى السيشن الرئيسية حاولنا ندخل عليها كانت مغلقة، وعندنا السيشنز الأخرى اللي موجودة كذلك مغلقة، فقط هاي السيشن مفتوحة. فنرجو من الأخوة القائمين على المؤتمر أنه يفتحوها، لأنه اليوم هو وقت إلقائنا للبرزنتيشنز الخاصة ببحوثنا. العفو، الأساتذة اللي موجودين أستاذ حسيم والست مرام المالكي، أرجو أنه يعني تقولون لنا أنه ممكن يعني استطعتوا أنه تدخلون على باقي السيشنز أو السيشن الرئيسي للمؤتمر. ست مرام. العفو ست مرام، قدرتي أنه تدخلين على سيشن أخرى؟ زين، عندكم وسيلة تواصل مع منظمين المؤتمر؟ يعني مثلا أرقام تليفونات ممكن تتصلون عليهم، لأن هون من خارج السعودية، أنا من العراق، فما قدرت أنه يعني عندي فد وسيلة تواصل، فقط عبر الإيميل. وراسل الست كريمة قلت لها اي استاذ ست مرة، ممكن انه تنزلي لنا هذا الرقم حتى نقدر نتواصل وياه، او انتم تقدرون مثلا اذا كنتم من دولة السعودية تقدرون تتواصلون وياهم، لانه انا من خارج القطر. فممكن يعني انه تنزلون هذا الرقم، وانا احاول وياهم، يعني راسلتهم على الايميل وما ردت علي ست كريمة.
خلاص تقدر تتكلم.
شغال دلوقتي كده، شغال دلوقتي ولا لا؟ هلو دكتور تاج. هلو.
Hello.
ايوه دكتور تاج. we will start soon ان شاء الله. just 2 minutes and we will ان شاء الله be. Mhm. Hi, Dr. Tech.
Hello.
Yes, please, you can start now.
Okay, one moment.
You have 20 minutes for your presentation, 15 for presentation, and 5 minutes for question, please, doctor.
So in total 25, right? Okay.
Excuse me?
In total 25.
Total 20 minutes, 15 minutes for your
Oh, yeah. Okay.
presentation,
Sorry.
and 5 minutes for question.
Right. Can you see my screen?
Yeah, I see it.
One moment. Let me just share my this part. One moment. I need to fix my sharing screen. Can you guys see?
Yeah, I see it. Go ahead.
Can you see, by the way, the screen in the middle, or you only see the presentation?
I can see everything, doctor. I can see presentation and hear your voice.
Okay. Okay. So let's go into the beginning.
Okay.
So hello, everyone. My name is Taj Saleh. I am a PhD student at Marmara University. And we have in this work, I work with collaboration with some of my colleagues in Medipol University as well, in Istanbul, Turkey. So our topic today is the performance and implementation comparison of two text matching algorithm or text searching algorithms, which is one of them is called KMP, the second is PM or bias mode in reflect to that. So today we will have a systematic review on the implementation and on different ways of how we compared between them, and also how did the modern architecture of CPUs or processors actually affected their performance, since those are a bit old algorithms as well. So let's So for today, I will handle those topic. I will start with my introduction and motivation. Then I will continue to my related work and problem statement. Then I will move on to the details of the algorithm, uh, each one of them, and maybe we can give some slide examples on how they work. And then I will move on to the methodology and experimental setup of my study very quickly. And I think some of the most time that consuming might be our results and analysis, since we have multiple different types of tests, which is, for example, text size effect, pattern size effect, and also combination between them and how do they affect the results. And then we will talk about the processor performance and differences because of different architectures. We will have some discussions and key takeaways. And then we will conclude, and maybe we can give some recommendations for future work, and we'll finish with a QA. Okay. So I would like to start by saying that in my introduction and motivation for it, that string search algorithms are the fundamental in many computing applications, from bioinformatics and DL sequencing to data mining and data science, which also includes search engines. Those algorithms are actually enable us to efficiently locate patterns in the large bodies of text. That's the main purpose of them. So, of course, among of the many algorithms that are available, one of them is North Morris-Pratt, which is KMP, and Boyer-Moore, PM, which reflects the designers or the ones who created the names, basically. And those are one of the most used algorithms in that field. And today we will be comparing between them with a variety of conditions. Now, what I wanted to talk is also what is the exact problem of this work. Then we will move on to what is the related work that has been done and what gap are we trying to study. So, first of all, our exact research question is which algorithm is more efficient in terms of running time, in terms of text size, in terms of pattern size, and how did some of the processor architectures that we have tested that reflects the new architectures or modern architectures affected their performance since previous old processors. So to explain the related work, I would like to talk about the table that I also designed as well, where I chose papers from the last 5 years that handle this topic. As you can see, not a lot of papers was found related to that topic. We can see that some of the papers actually does not handle the comparison of those two algorithms systematically. Some of them actually design it as a system, for example, for a web-based system or managing some documents. And other paper adapted one of the algorithms actually, which is PM algorithm, to handling very custom data structures. So it's not exactly a comparison type of thing. And then another work that is a bit more closer to our work, which is presented by Sarahan and Barakat in 2020, that handled both of the algorithms, evaluates them based on data file size, but not really with much details as well. So there was a lot of the details in his work that is not mentioned, and a lot of things he didn't cover that we also cover that gap in our work. And the rest of the studies does not exactly handle comparison by doing some testings. They basically do a survey and they do not provide any metrics related to their work. And then others deal with chatbots that they use one of the algorithms with it for different purposes. And as I can see, our dataset here actually is very clear about the dataset that is being used. It's used under different conditions. We use a very huge two datasets, one of them related to DNA and Latin, and also we directly compare between its implementation and under the various conditions, and also with the process that I mentioned as well. So that was our that was our condition for this as well. Okay, so let's start with the design algorithm for KMP algorithm. First of all, KMP algorithm is an efficient pattern matching algorithm, as I said, that eliminates unnecessary character comparison by using a pre-processing step. So normally, if you want to look for a search in a pattern in a text, you are going to start from the beginning one by one until you finish the text. But that's what's called brute force in this case. That's very, very slow, especially when you go into larger text sizes. So one way to avoid that is trying to skip matching or skip specific part of the text to checking it in the search matching or text matching. So KMP does this by creating a table called LBS table, or suffix table in this case, which helps us determine how much we can shift the pattern when a mismatch occurs, which means how much can I skip from the text if a mismatch happens, so I don't have to check it all over again. So so the first step would include that searching or creating that longest prefix suffix table. And then the second phase would be using that LBS table while searching, to avoid character checks or again from the beginning, and efficiently find the pattern occurrence in the text. So it proved to be actually effective, and under certain conditions, it's really, really good as well. One of the key advantages of KMP is that it runs on linear time, actually, with a time complexity of n plus m1. The building is O of m, and the searching for LBS is O of n as well. Now, so a small example on the implementation of it is that if you are trying to search for if you're trying for a text called this basically pattern, and you first of all you create the LBS table, and it should look like something like this in the list, where it reflects if a mismatch happened in each index, how much you can skip or where you start over from as well. So that is being used in the second step actually. So I don't want to go a lot into this. I wanted to show it case. Now, in the second part, the Boyer-Moore algorithm that we were working with is also a very common algorithm. And in some ways, it's much faster or a bit faster than KMP according to our studies. Now, it's very suitable for long large text and long patterns that we found out as well. But unlike KMP algorithm that tries to create an LBS table, we are actually creating two different things. One of them is we have two rules to generate. Bad character rule, that being help if a mismatch occurs. The pattern is actually shifted on the position of the mismatch character in the pattern. Now, bad character rule is basically a list of each character last occurrences in the pattern itself. So that will come handy later on in the calculations. And then good suffix rule is a suffix of the pattern has already matched. So you don't have to skip from the beginning of the pattern. You should find where it was most found within the text in the last time, and then you can decide on the algorithm where to shift your search if a mismatch happens as well. And then now, because of these two heuristics or methods that is being used in the algorithms, PMB has a best case complexity of O of n over m, and worst case of O n by m basically. So an average case of O of n, which is also quite good. Now that's a detail of how we can use it. As I mentioned, the quick example is that we start with the rightmost character of the example, and then if a mismatch happens, it shifts based on the bad character, and if a partial match happens, we shift based on the good suffix table. Now, to be able to directly compare between them, we can look into the table. We can find that most things we are really interested in is that BM algorithm actually shifts from right to left, while KMP shifts from left to right. So there, and also the main heuristics use bad character heuristics and good heuristics table in the BM algorithm, and also in KMP it's being the LBS table. And we will go over the actually other ones during the results part. Now, our methodology and experimental, we are using Python 3.9 on a system with 32 gigabytes of RAM in general. And also we tried different processors, such as the 6 cores i7 6700K, i9, 10 cores of i9 108050K, and one of the new architectures model from Intel is i7 12700K, and one of the most the new generation at that time that we used, which is R5 7600 6 cores CPU from AMD as well. So those actually use a variety of generations for our testing as well. Our data sets, as I mentioned, one of them is our DNA sequences of 1.5 million characters and the Latin text of 1.5 million characters as well. So as you know, those two different data sets represent a completely different type of texts, and actually there are different results for it. Now, as you can see here in the first data set that we have, we are trying to test for Latin data sets for our algorithm between KMP and Boyer-Moore. We can see that if you look in the y-axis, it represents actually the time or execution time in milliseconds, and the input size on the x-axis as well, by up to 1.5 million. Now, the way we run this is that each 1,000 character, we run the test on it of the algorithm, and then we increase it accordingly until we reach 1.5 million as well. So as we can see in terms of time, whenever the text size increases, we notice that Boyer-Moore or BM algorithm is actually substantially better than KMP in terms of execution time, as you can see. Also, when we move on to the second data set, which is DNA data set, we find in the similar case, but we can see that in general, on average, both of them take more time to run, but BM more actually is still faster as well, Boyer-Moore. So as you can see here, it reaches up to 150 millisecond, and here it reaches up to 300, but in the previous one, it reaches a bit less than that. As you can see here, it's around 50, here it's around 250 to 60 milliseconds, as you can see. So there is a differences between the type of text that you are trying to deal with here as well. So next, I'm showing the effects between the pattern size, where the pattern size is between 0 and 1 and 100. And as you can see, BM actually performs a bit worse in the beginning, then it gets better as well in the Latin. And then we the same case for the DNA dataset, although there is a lot more frequent disturbance in this case, but eventually it will move on to the same case. Now, our third case here is that we are trying to see the differences between combined effective text pattern and size. While we have, as you can see on the y-axis, it represents the text size, x-axis represents the pattern size, and the other side represents the execution time by how much of dark color it has. In the in DNA dataset for the BM algorithm, for example, in this case, we can see that in the beginning it takes a lot of time to finish, and then it moves on to be quite fast. And here also we see for the same dataset for KMP algorithm, we can see in the beginning it's a bit faster, and then it gets slower over time for the large pattern sizes and large data sizes, as you can see, which is 1.5 million in here. Here, the last thing I want to mention is the processor performance comparison that we will see. We can see that the worst one, which is I'm using as a baseline, is the oldest one, 6th generation Intel, in red. The second one is the 10th generation i9 Intel as well. Say again? Say again? Okay, I'll continue. So, and the latest Intel is actually, and the AMD are the two performing very similar in this case in DNA test. Then we move on to KMP. We see a similar performance, but we can see that Intel is a bit more obvious in KMP that it outperforms here. And then in processor of performance comparison for a different dataset, which is DNA latent text, sorry, we can see that for AMD in BM algorithm, actually in latent, it's actually outperforming all of them. So that's a difference between datasets as well. And we can see that also for KMP, it's consistent and still that Intel is still the best. So what we notice is that BM algorithm for a specific type of data such as DNA, almost AMD has better, actually is better in performance slightly than the latest generation of Intel, because the latest generation of Intel actually have a hybrid architecture of 2 different cores, unlike AMD as well. So take this into account as well. So I don't want to take more time from your time. Let me just finish with my remarks, and that what we conclude is that BM in general is superior to large text and large pattern sizes. But if you have, for example, small text and short patterns, KMP probably is better, up to 5 to 10 character sizes of pattern, which is more common in general. And then we can see the processor architecture impacts algorithm performance correctly by model architecture, but also different designs such as AMD and Intel might have different performance on different data types or data conditions, such as latent data, DNA data, text, normal text data. It will actually vary by the architecture of the processor itself. So there is a difference here as well that we noticed. So that was a bit more comprehensive analysis. And what is my recommendation for future is that we can work on parallelized versions of KMP and BM as well. And others method that we can work is trying to do some machine learning based optimization for pattern skipping, so that making our run times faster as well. So thank you all for listening. I tried to be as fast as possible and detailed as possible. Hopefully it was clear. Please, if you have any questions, please let me know.
Okay, thank you, Doctor, for your very good presentation. For the attendee, is there any question to the author? Is there any attendee need to ask any question to the author? Okay. Thank you. I have a couple of questions to you, Dr. Taj. First of all, you discussed 2 algorithms, very, very famous algorithm for pattern search, the KMP and the PM. As you said, KMP is working better when the string is short, and then PM become better. Could you find the margin or threshold to let us use KMP or PM? What is the size? What is the perfect size? Is this a function on what?
When you speak size, do you mean what type of size of text you mean?
Size of text we search in, and the size of the pattern as well. You indicate the search, the length of the string as a n, I guess, of length n, and the other of length m. Is that true?
True. So I think what I can give you as a recommendation is by looking at one moment is this. Up to here, as you can see, if you look at the very bottom left side bottom, you can see that if the data is quite large, for example, this is PM algorithm, for example, but the pattern size is actually very small, like up to 1 to 5 or up to 10 as well. It's going to take much more time than if the pattern was larger. So we can say here that up to, let's say, 5 characters, up to that, for example, the BM will perform worse on a very, very large data set. In this case, as you can see. So that's what my test result tells me. So if you want a number, I can say up to 5 to 10 characters. We should, if for large data sets, because in small data sets it's very fast. For large data sets up to 1.5 million and more, we ought to use KMP for small pattern sizes.
But there is no formula to control this operation between the length of the string and the length of the pattern we search for in the string, or just empirical result?
Can you clarify on how do you mean by that? Like, how do you want to control it exactly? Because sometimes you have in your data set, for example, you have a specific, like a set size of text, for example.
طيب, I have another question. To say that you apply your test on different machine with different process.
Yes.
It's okay. How you calculate the time, by the way?
Oh, okay. So first of all, we are using the time module in Python, but what you might be looking is how did you for example, let's imagine that we have the original text is actually 1.5 million. What I did is I divided them or segment them into groups of 1,000, right? So the first 1,000 I do the test, then I append the next 10,000 into 10,000 to it, for example, and then do the testing on the 20,000. Then I append the third one up. I keep doing that until I reach the full size of 1.5 million. So I'm segmenting the original data set into different patches, so I can check based on the size iteratively what will happen. So that's what I'm.
My argument is about if I run algorithm on a machine and for 5 minutes, how much of the 5 minutes is gained for your program or given to your program? How much of this? This is maybe you are run your program and there is a priority process running in the background, which captured most of the time. So running 5 minutes doesn't mean that you are consumed the whole 5 minutes to your application.
You're right. What I did, I tried to be closing everything, that any task that is running. I made sure in the experiment on my PCs, there is nothing else is running, because I did, as you're actually very right, I did notice that if I was running something else or even, for example, I'm running one of the browser, but I'm not opening anything, the performance was actually worse. So I did notice that. So I made sure for each of the testing that I close everything, close any task that I have seen that it will have any performance effects. So I avoided it by doing in that way, but there was not that's my method to do that as well. But yes, you're right. I did notice that as well in the beginning.
This can be a tool to be used as a benchmark, for example?
My method, you mean?
What you have done.
Yes, actually, it's
benchmark.
Yes, I mean, there is some initial results, as I said, in the related work as well, that agrees with my results as well. So it's not just previous work have some, for example, it says in general, KMP is not the very best in large data sets. So they have general remarks about it. So it agrees with my results as well. And I have extra results as well that I reported. So I think it can help, it can be very good as a benchmark as well. Because here as well, as I said, there is not much work has been done on different data sets and on it, like systematic review. But in general, my results generally agrees with other studies as well. So I think it should be taken as a benchmark.
Okay, thank you, Dr. Tak, for your nice presentation. And now we will go to the next presentation entitled Remote Blood Sampling Collection by Maha Al-Yazidi, Noor Al-Anzi, Ghaida Al-Amash, and Dr. Salma Al-Haj. Go ahead. Thank you, Dr. Tag.
Welcome. Thank you, everyone.
Who will present? Yes. Anand. You hear me, Miss Manal? Hello. Miss Manal, hear me, please. Assalamu alaikum. Assalamu alaikum. Miss Manal. السلام عليكم. في حد هنا معايا؟ في حد هنا معايا؟ السلام عليكم استاذ عاطف. حد معايا بس اي تي او كده بس.
تبقى الاي تي؟
اه.
عليكم السلام. ايه موجودين بس احنا يبدأ وقتنا 12 ربع.
لا انا بتكلم على اللي هو بلاد ريموت بلاد سامبلينج كوليكشن.
لا مو جروبنا هذا.
نعم. طيب طيب for the next paper, smart attendance management system in student housing, a case study at King Abdulaziz University. Is the author of this paper exists now? This author is not available online now. طيب مس مرام المالكي. Miss
Yes.
Maram Al-Malki is available.
Yes.
Yeah.
السلام عليكم، واضح الصوت؟
السلام ورحمة الله وبركاته. أهلا وسهلا. ماشي اتفضلي. You can start now, Miss Manal. Miss Manal is molecular precision diagnostic medicine in cancer. You hear me, Miss Maram?
Yes, we hear you. بس لو سمحت احنا ننتظر واحدة من الجروب معانا بس تدخل الآن وراح أبدأ أسوي شير. أوكي.
طيب اتفضل. ماشي، احنا 11 دلوقتي و55. مين؟ رنا اتفضلي يا رنا. ما احنا مين موضوعك ايه يا رنا؟
السلام عليكم.
رانيا.
السمارت اتندنس سيستم.
سمارت ايه؟ سمارت اتندنس مانجمنت سيستم. طيب اوكي،
Yes.
جو اهيد جو اهيد
اوكي
جو اهيد. رنا والبرزنتيشن it's about smart attendance management system in
Yeah.
student housing, a case study at King Abdulaziz University
Okay.
by رنا المبادي، بشير الحربي، روان العمري and سلمى الحاج. Can go ahead Rana please. Rana. Rana, are you hear me please?
Okay, so I will share my screen.
Yes.
Okay.
Share.
I shared now?
Not yet.
Not yet?
No.
No.
Not yet again. Maybe I bring somebody.
لأنه طالع لي إني أنا خلاص مسوية شير.
There is the R only. The R character R appear on the display. Have you start your presentation? PowerPoint is already available or not? Not yet.
Yes. Is it?
Not yet, Ramara.
طيب okay, I will stop this sharing. What about now?
Not yet. I
Mm.
will let somebody from the IT come to help you.
Because I'm MacBook. Is it that why? I'm using MacBook.
Not available yet.
Not yet.
Not yet.
So I will contact the IT.
Sharing. You are screen sharing. Huh? She want to share a screen, please. Stop. Yeah. and the other things are running.
حطه بره في الشارع خلاص، المكان اللي دائما العامل يحطه فيه، وقول له بعدين هو يرمي عشان ما يعمل ناس بالريح. ريحته سيئة، ريحته سيئة.
Share again, stop sharing مثلا. ثم نروح للرنا، فين رنا؟ The presentation appear in your screen, Rana, please.
Yes.
Yes, but you can make sharing for the screen. Have you make share?
Yes, now?
Yes, it's now working. Now it's working.
Okay, okay.
You have 20-minute Rana, 15-minute presentation and 5 minutes for question.
Okay. Bismillah ar-Rahman ar-Rahim. Hi, I am Nalma Abedi. I am here to present you our research paper on behalf of my co-authors. Our research paper discussed the need to adopt a smart attendance management system in student housing in our university, King Abdulaziz University. So, why smart?
There is some voice coming from your side. Please mute the sound, the other sound.
No, this is another. في واحدة مشغلة المايك مرام توقع مريم.
I can stop it from here. Yeah, go ahead.
So the reason why we choose to write about the attendance and student housing in our university, one of the authors are actually residents in student housing. And she was always complaining about how the whole system is paper-based and how it takes too much time to enter and exit and fill so many forms. So why a smart attendance management system? The first and main reason is the safety. Any student could access the smart or the student housing when he just have some few information about any student. So if one student in the student housing give another student his student card, and some information about himself, he could make it to the student housing. So the first reason we need a smart attendance system is for the safety. The second one is, of course, that any manual processes or any traditional manual process are often more time-consuming, inaccurate, and prone to errors. So we choose to propose a biometric solution where we have an biometric database and each student is registered in that database. So that will ensure only authorized individual can access. And it will give a more streamlined attendance and more automated attendance. So it will eliminate any traditional paper-based, and that, of course, will reduce the errors. And the third point is the real-time monitoring, where administrators could at any time access the data and get alerts for any unusual delays. So for the methodology, we adapt the business process management life cycles. It contains several phases. The first phase where we discover the process. With the help of Pisaji, we could make a model that represents the current manual system. It may not be very clear, but the rows represent participants that take place in this whole process. We could notice that we have 6 participants, including the students. And as we talk about the business process management, we have KPIs, business indicators, to evaluate our models. So we focus on 3 KPIs, the total cost, processing time, and student satisfaction. to highlight the areas for improvement. The second phase in business process management is the process analysis. We have a qualitative and quantitative analysis. For the qualitative, we draw the cause effect and Pareto chart. And for the quantitative, we made a simulation using Bizarre, where we fed the modular 1,000 students, and we see the key areas for improvement. We, of course, adjust some inputs as like the whole rectangle, blue rectangles, defined a process or one task. So we could put like some inputs for each task, how much it will take for time, the cost for each resources, and so on. So the modeler will help me make some processes to give an approximate numbers for the cost and time and so on. So here the third phase in business process management is the process redesign. Here we implement our 2P model. The model we see that it's fit the smart attendance management system, where we adopt as the system. So the system gives us two important, which is the fingerprint verification. Students can scan their fingerprints for authorization. So this will give me more security and data management. It will be much easier to manage the data when it is stored in database rather than paper-based. And of course, it will give me a real-time access for the administrators. So here, the results and discussions. For the quantitative improvement, we could, with the help of Bizarre, as I said, find that the new system will give us 92 reduction in processing time. This is in time saving, and cost reduction for 42.8%, decrease in operational cost. And for the security, of course, it will improve the security by eliminate any unauthorized access. For the qualitative benefits, we did a survey, a small survey for the student housing, for students in student housing. So all the students give a positive feedback about the whole idea of the system, the new system, and the whole new process. So we could say that the student will be satisfied by the new system. And of course, it will improve the security, real-time monitoring, and make the communication easier between students, security, and administrators. And we did the Six Sigma analysis. For the current manual system, we get like 2.3. And after the improvement, we get like 4.1 with the defect per million opportunities, reduction to 5,600, which is indicate a higher quality and consistency. So for the conclusion, as we saw, we could tell that implementing a smart attendance system would be a successful in enhancing efficiency, security, user satisfaction, and of course, cost saving, reducing processing time. And for the future work, we may focus on integrating some AI models where it's detect and recognize students through cameras, so no need for fingerprints. So no need for fingerprints devices, and we may developing mobile applications so all students could access their information from their phone, and implementing some cloud-based data analytics. So we could find buttons, some buttons, and so on, to enhance, of course, the system's capabilities. Thank you. Any questions?
Okay, thank you, Ms. Rana, for your presentation. Now, is there any attendee need to ask Ms. Rana any question about her presentation?
Thank you very much, the presenter. Kolawole Maruf from Nigeria. So thank you for that beautiful presentation. Please, I just want a clarifications on how you have be able to get the certain percentage for the cost reductions. What are those parameters you have used to have arrived at that certain percentage in the cost advantage of the simulation you have actually presented here today?
I'm sorry, mister. Are you asking about how we get that percentage?
Yeah, because the cost reduction, you gave us some certain percentage cost reductions.
Yes.
I want clarifications on how you have gotten that cost reductions.
So we use the Pizzaggi modeler, where we fit the model about like the salary for every resources, how much it costs everything. It's like an approximate numbers, but we get help from our co-authors who she already in the student housing. So when you feed the Pizzaggi these kind of numbers, it will give you like an approximate results, and we in the paper compare the results for the as-is model and the 2P models.
Okay, thank you very much.
You're welcome. Thank you.
Is there any question from the other? Okay, Ms. Rana, I have a question to you. What is the problem of the current system in order to use fingerprint system?
It's a manual system
Yeah.
where you have to go through multiple steps to just get the entry. And it's all paper-based, so you have to fill every time the same information, the same fields, which contains like 6 fields: a name, a student number, I guess the building, and so on. So, and of course, that's mean that give a less security, so any student could give his card number or his card, student card, to anyone to get into the student housing, which is something I don't think it's good in student housing.
There is another point also is, of course, in order to grant permit to come in or go out, there is certain rule which controls this process.
Yes.
The system depending on rule-based system, for example, and this rule, of course, can be changed from time to time. Is your system allow the rule to be changed, or you should change the code in order to be adapted to the new rules?
I'm sorry, I didn't understand actually.
Again, no problem.
Rephrasing.
To grant permit for certain student to go out, this is according to certain rule, which is set by the manager of the hostel itself. Is these rules fixed or can be changed from time to time?
No, as I know, it's fixed. So
why you don't make it flexible in order to one fit to all? The rule here in King Abdulaziz University is different from King Faisal, different from another university.
Okay, so you mean that new rule will be adaptable from multiple universities?
Your system become expert one, which you depend on rules, not just fixed. You are hard coded the rule inside the code itself.
Okay, yes.
Have you deployed this system?
No, actually, we didn't try.
Based on what you get the percentage, the values which you calculated in your system, if the system is not implemented, from where you get this percentage?
Okay, so doctor, as I said, it's using the Pizzaggi modeler. You could fit some inputs like how much the security guard takes as an cost, how much administrator get as a. You could fit some inputs that will help you to get the output. approximate output. So this whole percentage is approximate using the Pisaggio modeler.
Okay, Ms. Rana, I wish all the best to you and to go ahead and deploy the system in King Abdulaziz Hostel, inshallah.
Inshallah.
Thank you.
Thank you.
Ms. Rana.
Thank you, Doctor.
Thank you. Thank you. Next presenter, remote blood. Excuse me?
Molecular.
يعني I will check because molecule at the end, please. I will check for the one who remote blood sampling collection. Is anybody to present this paper existed with us now? I guess no. So now our presentation will go to molecule precision diagnostic medicine in cancer by Maram Al-Ghamdi, Gadi Al-Amri, Manal Al-Saddidi, Ghadi Al-Jari, and Salma Al-Haj. Dr. Salma Al-Haj present here 2 papers, I guess.
Yes.
Okay. Go ahead.
Okay. Can you see the screen?
Yes. Okay.
Okay. Bismillah. Good evening.
Good
We
evening.
are the group molecular precision diagnosis medicine and molecular. We grew from King Abdulaziz University. Ghadi
Who
and Ghadi.
Who will present? Who will present?
Ghadi Al-Shari. All the group.
Okay. Gadi.
Yes, all the group, but as now Ghadi.
Yeah, but your presenter is Gadi, yes.
Yes.
Okay.
We have choose this project in particular because everyone search to improve and develop and serve patients and doctor because they are interested in early detection. مرام روح السلايد اللي بعدها. In early detection because it's help and speed process of treatment and recover for patient يعني. And from the large and most dangerous disease until now is cancer. So we understood the traditional normal stage of detected and take long time. Also as in the screen, it's depend على patient history and basic lab test. Also the information it's provide generic health informations, not specially. Also the detected general abnormally, it's not detected specific. But in the molecular diagnosis, it's focused on molecular and genetic tests and characteristic of genetics to diagnosis type of cancer. So the results are not specific and in traditional, so that why we choose molecular in early detection in cancer. Okay, we study for it and analyze the studies, all the studies, and the objective of projects it's improve integration, advanced diagnosis and genetics test to early detection and help the doctor and patient for better treatment and recover. Now, Maram, it will be continue with you to background. Maram.
Assalamu alaikum. Yes, will be continue background and related work. Molecular precision and diagnostic medicine are transforming how we approach cancer treatment and management, showcasing advancements in artificial intelligence treatment, modality, and some research regarding pharmacological application. The first one is the treatment. The first treatment is biomarkers. In precision medicine, guiding and logistic and selection the best cancer treatment, but they don't solve all practical problems due to heterogeneity issues. The second is multi-omics. The use of multi-omics data to personalized cancer treatment, focusing on genomics and proteomics and metabolomics to better understand cancer and patient response. The final is liquid biopsy. Liquid biopsy in oncology, highlighting technological advancement and clinical scenarios. It is a solution for earlier cancer diagnosis and monitoring. The second is for medical application. The first, molecular profiling, can help understanding biological complexity and compounding risk and treatment, and use unique biomarkers to deliver personalized treatment. And the second is proteomic analysis. The proteomic analysis is used for diagnosis of tumors, aiding in therapy solution and improving understanding through the combination of data from genomic and proteomics. We'll continue with غدي.
صوتي باين واضح؟
Yes.
In our methodology, we used business process management, which is used in large companies and even in hospital and in healthcare facilities. Our goal was to develop, improve, and optimize the process. To achieve this, we followed a structured methodology that included three main analyses: as is, qualitative, and quantitative analysis. In as is, we studied the current state of the process. In a quantitative analysis, we examined how the process impacts the patient's life and what improvement it can bring and how it can enhance the overall experience. In quantitative analysis, we focused on the measurement and the numerical data to assess the efficiency and identify the key areas for improvement. روح السلايد.
What's the problem?
After analyzing the current process, we moved to redesign phases to create more advanced and efficient.
Please, sound is not coming out.
We listen. Yes, we listen.
Do you hear me now?
Yes, we.
Manal,
After
sound
analyzing.
is coming out, Maram.
No, it's not Maram. Now غدي is represent. غدي العمري.
After analyzing the current process, we moved to a redesign phase to create more advanced and efficient approach.
Sound is not coming out.
Can you hear me now?
Yes.
Can you hear me now?
Ready?
Yes, I'm talking.
Mister. كملي.
Mister, are you here? Can you hear me?
No voice, Maram, please. No voice. I don't know what's the problem. Voice, no voice.
Now?
No, not the problem. From the speaker. That's no voice.
Mister, can you hear me now?
Mister. Mister, are you here?
Hello, can you hear us now?
Yes, we can.
Go ahead, please. Yeah.
Can you hear me now?
Excuse me?
Ready.
Yes, we can listen. Completed.
No, complete, please.
Alhamdulillah.
After analyzing the current process, we moved to the redesign phase to create more advanced and efficient approach. Our goal was to enhance the diagnostic process using technologies and ensure better outcomes for the patient. In a 2B analysis, we integrated molecular and genetic testing, which provide clearer and more accurate pictures of the patient's condition. This allows for better diagnosis and the treatment decision. In the simulation phase, we used simulation to evaluate the effectiveness of the new process and measure improvement in time, cost, and the diagnostic accuracy. In the implementation phase, we used Visagi modeler to transition from the traditional diagnostic approach to the advanced molecular precision diagnostic cancer model, making the process more precise and efficient. For more details, now we will continue with Manal.
Assalamu alaikum. Process monitoring and controlling.
Okay.
Before simulation, as is a process, simulation revealed long diagnostic timelines waiting for lab results before imaging. And you hear me?
Yes.
Okay. And lack of prior patient information and the use of simple tests combined with manual interpretation and increased costs to the patient made it more likely that cancers would be missed at an early stage, leading to their spread and difficulty in controlling on it. But here, after simulation, using the platform and AI assist data processing and linking molecular diagnostics and genetic analysis to imaging. In the 2B process, simulation was able to reduce the total diagnostic time from 8 days to 6 days, reduce costs as the patient would only pay for the first visit and would not have to pay for each visit. For the visit and would not have to pay for each visit, in addition to increasing the accuracy of both diagnostic genetic tests and AI models within the two.
Yeah, go ahead.
Both diagnostic genetic tests and AI models within 2B process, which would reduce the misdiagnosis rate to 5%. In discussions and conclusion, this paper studies the molecular diagnostics of cancer and its effectiveness in detecting cancer in its early stages, even before symptoms appear. It may also provide prevention treatment plan for individuals at risk, as shown in the current process using Visagi. Used to take longer as it relied on imaging and basic tests, X-ray scan and radiology, in addition to some blood tests and urinary analysis, which makes it a diagnostic tool with an accuracy of 75%. After improvement and development process, we using also Visagi as shown in the process. The diagnostics process became faster and took less time than before, as the accuracy increased with genetic tests and molecular diagnostics by 95%, which will improve the process of detecting cancer in its early stages. And in the future work, inshallah, genetic testing and advanced diagnostics could be integrated into a single platform, ensuring better early detecting of cancer. The process would be able to detect cancer early, even before physical symptoms appear. Also, patients could be offered early treatment with increased chances of successful outcomes, which could potentially reduce the mortality rate from cancer. It also allow for preventative treatment strategies to be provided to at-risk individuals. Thank you.
Thank you very much for you and your team. Is there any question for this team? Is any of the attendee need to give a question for the team of this paper?
Hello, thank you very much.
Okay, go ahead.
Thank you very much, the moderator. And I want to thank all the presenters on this particular topic. It was very interesting topic.
Thank you.
However, you perform some simulations during the course of your experimentation or analysis, and you do not make mentions of the software tools used. Now, that is the first question. The second question, was any validation done? And if yes, can you explain? Hello?
The first question about software, we use Visagi, but the second question, we not get what you mean in
I
this.
said, did you validate your results?
Yes, we validate.
And how was the validation done? How was the, how do you validate your results?
After we finish the model in Visagi, we take sample of data to check and validate. But then we got the result, يعني.
All right. Well, I think validation is also very important because it's strengthening the accuracy of your results. Software is like garbage in, garbage out. So unless the designer actually perform a very thorough validations before you can now say, yes, you have some certain percentage of efficiency in whatever you are doing. And that's why I'm asking that question, that was any validation done? So if yes, oh, that's good. But if validation is not done, maybe in your future work, you can consider that validations before starting employing that software in any simulation work.
Yes, in stage and validation, we need for sensitive data for patients. So we talk about some hospital, but not received confirmed because we need actually information for real patients, because the molecular it's depend on genetic test. So we need all the history of genetics and real patients, and it must be an early stage of detection and is not transformed for chemo.
Okay, thank you very much. But maybe in your future work, you need to concentrate that. That's one of the first thing in using any software. Thank you.
Thank you, Doc. Really, I have one concern about the research, this research. Who is decided about traditional and the new method? Is it who is it yours or a doctor's physician?
لا, it must be with the doctor.
Doctor.
All the two types, traditional and molecular, it must be with the doctor.
You are not the founder of molecular process. The founder is somebody else. Because
yes,
I don't see in the team any physician with you in order to tell you this is a best or not best or whatever. The team all technical person. How you get
no,
this
we need
information?
technical team. We need technical team because the information of patient is must be classification for it's important or not important. It's the most one or not. So technical team, it must be work in platform. The platform take information from doctor after doctor do lab test and everything for patients. Then technical team, it must be track all information to keep it all information clear and correct, because the platform, it must be match with format same data.
Okay, thank you very much. Thank you.
Welcome. Thank you. Welcome.
Is the other team which is not presented on time? Is anybody remote blood sampling collection paper? Is somebody here? Ghaida. Ghaida is here. Please reply, Ghaida, if is any member of the paper entitled Remote Blood Sampling Collection with us now? Okay, so by this paper we ready. Look, somebody is trying to come in. معروف.
Thank you very much. My paper was not scheduled for today. It was scheduled for tomorrow. So I'm just joining the conference session.
Yeah. Is there is anybody for the paper remote blood sampling existed with us, please? Okay. We end this session of today. Thank you for all the presenter, and see you afternoon, inshallah. Thank you very much. Bye-bye.
Thank you very much, the moderator.